Hello everyone and welcome to today's webinar, Teaching Old Data New Tricks. My name is Sai Reddy. I'm a Solutions Architect with Amazon Web Services. We also have Brian Barker, CEO of NorthBay Solutions, Sean Popolo, SVP of Engineering for Elijah Corporation, and Ali Khan, Director of Business Intelligence and Analytics from Scholastic, presenting with me today. With that said, let's get started. This is a high-level agenda of today's webinar. I'll do a quick overview of big data on AWS and why AWS for big data applications. After that, I'll hand over to Brian from NorthBay, who will do a quick overview of NorthBay and their services. And then we'll do a deep dive on Elijah Corporation case study and Scholastic case study. So in this 21st century of digital economy, the amount of data being created and collected is growing and accelerating significantly. According to the research from IDC, the amount of digital data being created globally is doubling every 2 years, and only about 0.5% of the data is ever analyzed. So big data can be described in terms of data management challenges that due to increasing volume, velocity, and variety of data cannot be solved with traditional systems. Despite the hype, many organizations don't realize that they have a big data problem, or they simply don't think of it in terms of big data. In general, an organization is likely to benefit from big data technologies when existing systems and applications can no longer scale to support sudden increases in volume, variety, and velocity of data. Failure to correctly address big data challenges can result in escalating costs, as well as reduced productivity and competitiveness. On the other hand, a sound big data strategy can help organizations reduce costs and gain operational efficiencies by migrating heavy existing workloads to big data technologies, as well as deploying new applications to capitalize on new opportunities. So the research from the analyst firms is pretty clear. The data is growing and companies can benefit by analyzing the data, and companies are looking for the right tools and technologies that can provide them valuable insights from their data. So why AWS for big data? So AWS provides the broadest and deepest capabilities for big data applications. AWS provides a highly available, scalable, secure platform with broad and deep capabilities. So what do I mean by that? So most big data technologies require large clusters of servers, resulting in long provisioning and setup cycles. With AWS, you can deploy the infrastructure you need almost instantly. As requirements change, you can easily resize your environment, whether you can scale up or scale down on AWS to meet your needs, without having to wait for additional hardware or being required to overinvest to provision enough capacity. This means your teams can be more productive, it's easier to try new things, and projects can roll out sooner. Big data workloads are as varied as the data assets they intend to analyze. A broad and deep platform means you can build virtually any big data application and support any workload regardless of volume, velocity, and variety of data. With 50 plus services and hundreds of features added every year, AWS provides everything you need to collect, store, process, analyze, and visualize big data on the cloud. Big data is sensitive data. Therefore, securing your data assets and protecting your facilities and infrastructure without losing agility is critical. AWS provides capabilities across facilities, networks, software, and business processes to meet the strictest requirements. Environments are continuously audited for certifications such as ISO 27001, FedRAMP, DoD CSM, and PCI DSS. Assurance programs help you prove compliance with 20 plus standards, including HIPAA, CESG, and more. In most cases, big data processing comprises of various stages, like a workflow, such as ingest, store, process, and visualize. The right technology in each stage is based on various criteria, such as data structure, whether it's structured data or unstructured data, the type of queries, the latency, the cost, the retention rate, the request rate, data volume, and durability. AWS has an ecosystem of analytical solutions specifically designed to handle offerings in different stages of this big data framework. For example, our AWS Import-Export is a service that accelerates transferring large amounts of data into and out of AWS using physical storage appliances, bypassing the internet. With Snowball appliance, you can transfer hundreds of terabytes or petabytes of data between your on-premises data centers and Amazon Simple Storage service. Our Amazon Simple Storage service provides developers and IT teams with a secure, durable, highly scalable cloud storage. Another service is Amazon EMR. Our Amazon EMR provides a managed Hadoop framework to process vast amounts of data quickly and cost-effectively. You can easily provision a fully managed Hadoop framework in minutes. Another service is Amazon Kinesis. Our Amazon Kinesis provides a platform for streaming data on AWS, offering powerful services to make it easy to load and analyze streaming data. Another service is Redshift, which is a columnar-based data warehousing service that can process petabytes of data. So with a big set of services, customers has access to process and run any type of big data workload on AWS. So what are customers doing with big data on AWS? Our customers are running a wide variety of big data applications on AWS. They're using AWS to build big data repositories, doing ETL processing, running analytics, creating smart applications using machine learning. With AWS, you can build virtually any big data application. These are just few examples of how some of our customers are driving value from big data with AWS. With that said, I'll hand over to Brian from NorthBay to talk about their services.
Hey, thanks, Sai. Hi, everybody. This is Brian Barker, and I'm the CEO of NorthBay. And today we're going to be discussing a really exciting new model called Teaching the Old Data New Tricks. Both Amazon and NorthBay are really excited about it, and you're going to hear what Sai just mentioned from the words of two customers, Scholastic and NorthBay, Scholastic and Eliza, who are great NorthBay customers. And you're going to hear two of the usage patterns around teaching old data new tricks. We've in fact codified 16 of these use cases. So sometimes in the middle of a seemingly routine project, something really great happens and the significance isn't really immediately apparent. So this happened to me a little bit earlier this year when one of our customers, in fact, Ali Khan, who you're going to be hearing from later today, said, it was our same old data. We get so much more value from it. It's been re-energized and reinvigorated. And this was a really impactful statement. And the reason I say that is he exposed a universal truth. In virtually every company on this webcast, and in fact I would say every company in America has this vast pool of untapped wealth in their old data, and further in combining that old data with new data. So today we're going to look at is what is the key to realizing that data wealth. And that's unlocking it, re-energizing it, reusing it, recombining it, and making it available to users. And those users can take actions with new customers, get insights, and solve problems for some of the existing customers. So we realized that if we can help our customers develop and implement this teaching old data new tricks model, they're going to reap enormous rewards. And when Amazon heard this, they get excited too, and that's why we're here today. So what does this really mean? Well, two really great customers, Scholastic and Eliza, will be telling you their story. Scholastic will tell you how their market has changed. It's continuing to change dramatically, and they need to proactively evolve with it. So they're an old school, 100-year-old company that most of us on this webinar, and maybe our parents and children too, have bought books from them over the course of their 100-year career. And they're in the process of retooling their environment for the next 100 years. They had old school IBM and Microsoft systems, and those systems were really great in their day, but that day had passed. So how did this iconic company reinvent its old school big data system and analytics system on the fly? And you'll hear later from Ali Khan, and he's the man who led that change, and he's going to give you what I think is the most interesting perspective, and that's an insider's view of, where did they start? What do they decide on for technology and partners to implement, and why did they do that? What factors were really important for them when they were making their decision? How did they implement, and what lessons did they learn, and what results did they achieve? So I guess I was asked to talk a little bit about AWS and NorthBay, and Cy did a great job on AWS. I'll just focus on NorthBay for now. So we solve really complex problems for companies like Cisco, FedEx, Humana, Liberty Mutual, Eliza, and Scholastic who are joining us on this webcast. We've also solved complex problems for really promising startups, so people you've heard of and have been acquired by companies like Facebook and LexisNexis. So companies like Pharmascience or Vungle or IntelliGize, GameView, Tapjoy. Tapjoy, by the way, just had their billionth download about 6 months ago. So we're really proud of our organic growth, and in fact, we've grown to 200 people, more than 145 clients. And for those clients, we've launched over 250 solutions. And sometimes I'm asked, what does growing organically mean? Well, NorthBay has never needed to raise money. We felt that if we focused on solving tough problems and finding technical rock stars to add to our team, that'd be good enough. And certainly over the last 5 years, it's led us to that great growth. So we hope that there are some companies today who we can work with and solve some tough problems for you. And sometimes when we do these things, really good tech people want to investigate joining our merry little band here. And if that's the case, you can get a lot more information about NorthBay at our website or LinkedIn or at reInvent. So some of the things to look for, John Popolo is going to talk next, and he's going to talk about conceptual data lake architecture. And some of the things that you should look for there is, first of all, data, as I had mentioned, is really ever increasing. And can you develop a structure that will scale as large as you ever need to get? So things like logs or applications like Salesforce or SAP, databases like Oracle, XML data, multimedia, social, chat, people data, all this data is ever increasing, and we need a way to deal with it. So what we think in teaching old data new tricks is we're developing the scalability. The next question I think you want to look at is, can my future solution accommodate and incorporate high-speed data? And if you can blend this new data that didn't even exist a few years ago with your old data, well, then you have the fullest insights and are able to make the most actionable decisions. Along with that, you want to look about, is the schema flexible? Can it store both structured and unstructured? Is it storing it in organic data format? So if you look back to traditional legacy data systems, you would have to do a schema upon import or write. But that implied that you knew exactly what you would be doing with the data. And that also implied that you were making the right decisions up front for something you would need years from now. Well, that's not possible. So today's data lakes, we're able to import all the data. And once we do that, later on, users, as their needs evolve, can then structure upon read and when they're utilizing the data. So this really offers unmatched flexibility to ask any of the business or domain questions and to gain insight and the business intelligence answers that you're looking for. In short, other things you're going to want to look for when John's talking is the ability for the data lake to provide speed, flexibility. Is it future-proofing for new data sources that will evolve? And finally, are you going to be able to get the advanced analytics and combine these really large quantities of data along with deep learning algorithms to allow you to empower real-time decision analytics? So next up is John Popolo, and I gave you a little bit of an insight on him, but he's just going to tell you he's the guy who led the change at this really high-flying healthcare services company. And they had to re-platform their entire enterprise data platform while doing millions of transactions each and every day. So he's going to tell you about why they did what they did, what strategic goals were they were looking for, why did they choose a data lake, AWS, and NorthBay, how did it turn out, and and just the insider's view of exactly what he did and why he did it. So I want to introduce Ali Khan. Ali Khan was the person who decided what Scholastic would do and then led the charge as far as the implementation. So Ali, very pleased to introduce you.
Thank you very much, Brian. Thank you, everybody. My name is Ali Khan. I'm the Director of Business Intelligence and Analytics at Scholastic. As well as those two domains, I also have responsibility for the overall data platform, and that's what we're going to be talking about today. First of all, I just want to introduce Scholastic. If you have children or if you know a teacher or if you've been through the school system here, you're probably familiar with Scholastic. It's a company that when I tell people I work for, they sort of, their eyes sort of well up with childhood memories. So that's always a nice thing. But we are the largest publisher of children's literature in the world. We're also known for our educational materials as well. Most people, associate us with, the Hunger Games and Harry Potter and things like that, but we actually do a great deal of work in the classroom as well. So Scholastic is, one of those interesting companies that sort of has one foot in the traditional print world and one foot sort of in this emerging digital world, and I'll talk about what that meant for us. Brian introduced this session as being about teaching old data new tricks, and we have a lot of old data, right? We have systems that have been running for 25 years or so. These are old AS400 systems, if you can believe that. These are DB2 systems, right? The data warehouse that has been built out of that is at least 13 years old. So, there's a great amount of data. So for a data person, this is actually, very exciting, right? One of the reasons that I joined Scholastic is because, I feel that, there's an immense amount of data here. And when I first joined 2 years ago, that was the number one complaint that I got. We have all this data about American school children, about their reading habits, about teachers, about schools. We could be doing so much more with it. But that was very difficult, as we'll see as we go through this. So what Scholastic had built over the years was a very typical 1990s style data warehouse architecture, right? So if anyone is working in an enterprise where they have had a Kimball style architecture, this will be very familiar to you, right? You have core data warehouse tables, you have marts, you have cubes that are built on top of that. There was a layer that was really around the collecting the data from the AS400 systems, and then there was another layer on top of that which is really concerned with getting data ready and ingested for the reporting layer. So just from this brief description, you can understand that there were at least 4 or 5 layers here, and in each of these layers, the data was persisted, in another form, ostensibly for good reasons. This was done for reasons of integration or reasons of performance and so on. But what it meant was that we ended up with an inflexible architecture. If you need to change something now in this data warehouse, you don't need to change it in one place. You need to change it in 5 different layers. And so, when you're in a business, when you're in an industry that is changing rapidly, that becomes a real concern. On top of this, the system was just unable to meet its SLAs, right? There are hundreds, actually thousands of jobs on the AS400 side that run daily, nightly. It was just a challenge to kind of get the data prepared and ready and available, let alone really begin to explore and unlock the value that was inside it. We were quickly reaching the limits of what we should be doing on the cube side, right? So if you're familiar with cubes, these are the multi-dimensional pre-aggregated structures that are a great idea, but what tends to happen is people tend to add more and more dimensions, in fact, more and more dimensions into these things, more and more low-level data into it, until it sort of defeats the original purpose of the cube, which was to give a quick insight into the data. It really becomes sort of onerous. It develops what I call the Swiss cheese phenomenon. And so because of all these reasons, we really had a very limited ability to perform any kind of self-service. So there's a lot of frustration all around. So we launched this project with really a few goals, which kind of are the inverse of what I just mentioned, right? And I'll just highlight a few of these. Obviously, we wanted to enable a great amount of self-service, right? This is sort of the number one request from the business. And also, as a technology team, we wanted to get ourselves out of that area. We wanted to not be the middleman, in that interaction. We needed to integrate with our existing technology stack, right? AS400 is not going away anytime soon as the source system. We have, extensive systems around, monitoring and so on, and all of those need to be integrated well into this. We are developing a technology strategy here at Scholastic, which is cloud first, DevOps centric, right? And we wanted to have, technology that reflected that. We also have people who have very deep skill in the discipline of data warehousing and in data quality. We have folks who have worked in the original systems. We have folks that we have hired just out of college, and we have a very, very sort of richly, stacked team here. We wanted to make sure that we leverage their skills as well. But at the same time, we recognize that we need to team up with an experienced partner if we're really going to excel. So, the decision. So AWS was not a difficult decision. We were moving in that direction as a company, and so we took a look at what AWS had to offer, and it had a rich data stack, and so we were immediately kind of drawn to that. Redshift in particular, which forms the core of our system, was very familiar to us, right? Anyone who had worked on column-oriented databases or MPP data warehouses like Teradata was immediately understood what this was. For our broader team, this was very familiar because this is still a SQL centric relational database. So it was important from a learning perspective, from the perspective of the learning curve not being too steep. Finally, NorthBay, we chose as our partner. They were actually recommended, by Amazon as one of the companies that we should look at. We spoke with them, and they had specific expertise in doing migrations, and that was what we wanted. We wanted a partner that could, we could say, hey, show us how you've done this before, and NorthBay was able to do that with competence and confidence. So how did we begin? We started with a pilot, and the goal of this pilot was to take a particular line of business. In Scholastic, we have several lines of business. Some are focused, on the school. Most of them are. Some of them are focused on, the trade business, so on. So we chose one particular line of business, and we ran a 12-week pilot. And in that pilot, the goal was really to, stand up the environment, prove that we could create this environment, and that we could migrate data from the AS400 systems into this and have that exposed and deliver some immediate value to the business. So the outcomes of this, the most important outcome, was that we developed a framework, and I'll talk a little bit more about that. We spent quite a bit of effort working with Amazon and working with NorthBay in developing a custom framework so that we could move data reliably and in a repeatable fashion from our source systems into AWS. We also had built, along with that, a system to be able to validate the data and capture metadata about it as it was flowing in, so that we had the appropriate operational metrics. And coming back to the self-service theme, we also wanted to make sure that once we had all of this data captured and presented, we could also present it well. And Tableau was our tool of choice for that particular operation. So a little bit about the technical architecture. I won't go into depth on every component here, but in a nutshell, sort of flowing from left to sort of right and then back down again. You see our source systems here. The bulk of our source systems are still AS400 systems. This is DB2. And this is flowing into this rectangle here really sort of represents our custom data ingestion framework that I mentioned on the last slide. So this was a Python program that we had built as a container around several AWS services like Data Pipeline, as well as Scoop, which really formed the heart of it. Scoop is an open source database migration utility or data movement utility. So we had this data captured, we brought it into S3, and then we staged it in Redshift and eventually moved it into the warehouse. As we were doing this, we also were capturing in DynamoDB data about the operational the operations that were occurring. So how long are each of these steps taking? And that's, we're very attuned to that, right? Having come from an environment where performance was a real challenge, we really wanted to understand, how we were doing. And the main output here was through Tableau, right? Tableau is not the only tool that's in use here. A lot of people are still using, Microsoft reporting tools, but Tableau is sort of the tool of choice for data exploration and visualization. So just a little bit more about the framework here. I already mentioned about DynamoDB, but one of the key requirements was that we integrate well with Control-M, which is our enterprise scheduler. So that required some custom work from ourselves at Amazon and NorthBay, and that was working well as well. Another key requirement is really to have this framework be restartable, right? If there's an issue with the source system, which happens quite frequently, we need to be able to detect that. We need to be able to stop and start these jobs, and also, we need to make sure that if there's an issue with a feed and we have dozens and dozens of source systems, we're able to isolate that and understand exactly what's going on. So we built all of that into the custom framework as well. So Tableau, a little bit more about that. So one of the reasons we like Tableau is it really kind of upends the traditional need to sort of pre-aggregate data in a data warehouse, right? So what I mean by that is, we're able to explore data sets sort of on the fly, right? And this is a great boon for our analysts. They're really able to use the data, and without sort of waiting for a tech team to build sort of some intermediary structures, they're really able to get a lot of value and insight into the data before moving on. So we have various levels of users, right? We have folks who are, we call analysts, who are really analysts, and they have full access to the data, external sources as well. Then we have people who are more consumers of that data. These are your typical dashboard users. So after we launched the this initial pilot, it was well regarded. We had proved that we could move data in. We had collapsed the timelines for the data to be moved in significantly, right, from hours down to minutes sometimes, and we were able to visualize this data. This was really well received, and we were asked to accelerate the timeline of this project. And the goal was that in 18 months we would have the entire company, all of the enterprise data warehouse, 6 lines of business or functional areas migrated over all of their data, all of their history, and have all of them have users that were able to access the data through this. This system then got a name, right? It's the Scholastic Data Cloud, and we were really asked to sort of accelerate this program. So that was a real challenge, and we did a lot of sort of brainstorming with internal project people here, as well as our partners in NorthBay. And what we basically came up with is that we would execute several teams in parallel, right? Each team would be responsible for migrating a line of business, to migrating their data, to visualizing their data, making sure that the users were supported, and so on. One of the things that really kind of made this happen was that once users had seen the benefits of being on the new platform, they asked to be on it, which is was a good thing to have. Some of the lessons that we learned from a technology point of view is, obviously when we needed to go in parallel, we needed to make sure that each team could work independently, on its code base. That's a fairly normal practice, but here at Scholastic, we were sort of quite behind the curve on engineering best practices. Typically, our group had sort of centrally developed everything. There was one group, and now we needed to have 7 development teams working in parallel. So we embraced the code ownership, code sharing, and code isolation. We also had to I already talked about the custom framework, so I'll skip that. But we also had to really improve our ability to do automated test-driven development. And this is sort of a challenge for us, because a lot of the tools that are out there are really geared toward procedural programming languages, right, and not toward SQL code, which is most of what we write. But eventually we did find a tool, which is Query Surge, and we're now using that, and that really has improved the quality of the code that's being developed, and the speed with which we develop it. And finally, we'll talk about some of the lessons that we learned on the program side. So one of the reasons we were asked to accelerate our program is because our management did not want 2 very large platforms running in parallel, for obvious reasons. So as we were standing up this new platform in the Scholastic Data Cloud, At the same time, as we moved the line of business over, we wanted to decommission the system that it came from, or the subsystem of the enterprise data warehouse that it came from. So this is a real challenge, right? Standing up new systems, it's not without challenges. A fair amount of brain work went into figuring out how to move data from the AS400. Apparently, according to Amazon, we're the only people to their knowledge who are doing that, or amongst the first, or maybe the first. That was the easier part, right? The more difficult part was decommissioning the existing platforms. And that's because people are just used to doing things in a certain way, used to the platform, and that was a real difficult exercise in sort of change management, which we're still going through. The second thing is, I had alluded to the fact that we had sort of analysts. So we gave them a title, right? We called them data champions. And the way that we, partnered with them is that we'd give them a person on our side called a data guide. So these two people would really partner together. So each of these lines of business would have a data champion who's sitting in the business, and they would have a data guide. And these people they're sort of similar in that they're both, sort of business analysts, they're experts in the business, they're experts in data analysis. The data guide on our side is particularly expert on, the data and the tools, and their job is really to mentor the data champion. The data champion on the business side would then become the the sort of the internal champion for that line of business, getting people to use the new platform, training them in Tableau, helping them get started, and that made a real difference to the adoption of the new platform. And finally, and this is more of a sort of a project management thing, we work in an agile fashion here, and we need to scale up from one team basically to about 7, right? Really big expansion, and to do that, we learned the importance of really having very good agile coaches, so that our teams could spin up well, and that's about it. I look forward to answering your questions. I see some of them popping up in the Q&A.
Thank you, Ali. That was excellent. It's really rare that you get an insider's view from such a large project. And we're fortunate enough to have you give us that, and John Popolo from ELIZA has also been able to rejoin us, and so now we're fortunate enough to get a second insider view. So I wanted to introduce John Popolo, VP of Engineering for ELIZA.
Hello, everyone. I'm John Popolo, Senior Vice President of Engineering at ELIZA. Founded in 2000, ELIZA focuses on health engagement management and acts on behalf of healthcare organizations such as hospitals, clinics, pharmacies, and insurance companies to help people close clinical gaps. Our mission is to engage people at the right time, with the right message, and over the right channels in order to improve population health and provide objective data to our customers relative to their efficiency and effectiveness. ELIZA helps its customers engage in the pay-for-performance model. In this model, the payers and providers are incentivized to keep focused on the care and well-being of the populations, and it's the outcomes that matter most versus the number and types of services people receive. This is definitely a big job and requires us to process and analyze a good deal of data. For example, we process the healthcare data for over 55 million Americans every year. This translates to millions of interactions per day and hundreds of millions of interactions per year. A handful of our key stores house approximately 1 trillion records. So this creates some challenges, as you might imagine, that we'll talk about. So ELIZA analyzes more than 300 million outreaches per year, primarily through outbound phone calls with interactive voice response or IVR technology. But other channels such as SMS, email, and inbound IVR are growing quite rapidly. For ELIZA, interactions take the form of healthcare questions and answers. The questions are implemented as a decision tree, and we capture each unique question-answer pair as a tuple. An example would be something like, did you visit your physician the last 30 days? Yes or no. This means that ELIZA captures and needs to process millions upon millions of name-value pairs continually. Keeping the data in its raw form is important, as it makes analysis and reporting as flexible as possible. Imposing a schema on write can limit our ability to do ad hoc and what-if analyses. Additionally, our internal clients, such as data science and analytics, need different slices and views, as they use the data in very different ways. Serving multiple diverse groups can be quite challenging if data conforms to a single rigid schema. It's interesting to note that we used to store all of these pairs in Redshift and had to pivot them for downstream consumption. Over time, this pivoting became extremely time-consuming, leading us to rethink our data strategy. Our strategic goals in developing a next-generation data platform was to create an architecture to support continued growth and new functionality, allowing for maximum flexibility in analysis and reporting. Also to have the ability to ingest, transform, and process old as well as new data streams. We also wanted to allow for both real-time and batch processing with little human intervention. In addition, we set out to provide metadata, a catalog, and discovery capabilities for content in the data store, to enable and control access to data through entitlements and governance, and to increase the level of self-service for our end users. These needs led us to consider a data lake architecture. The conceptual architecture shown here has three main layers. So moving from left to right in the diagram, we first have an ingest layer that accepts a variety of data formats along both batch and streaming pathways. Moving to the right, we have a conditioning layer where data quality and governance rules can be applied, keeping corrupted or inaccurate data out of the lake. At this layer, we can also generate and add metadata to any and all data streams. The metadata supports search, discovery, and intelligent lifecycle management scenarios. On the right, we see a consumption layer where downstream clients can access and subsequently analyze the data. In addition to these primary layers, this canonical architecture readily supports data access control and centralized auditing. So some benefits of this platform. We'll talk about one set of benefits, then talk a little bit about the architecture, then talk about the architectural benefits. The hub and spoke model provide a single copy and single source of truth for all enterprise analytics data. This prevents us from having to make multiple copies of the same data and limits data transitions. We're able to take manual processes out of workflows and streamline and automate ingestion of the source data. We can apply consistent quality checks, transformations, and conditioning, keeping the operational data reliable and clean. We can apply consistent centralized access through entitlements and role-based security management. And we can service multiple downstream customers through projecting the data as needed. And we'll show this, the projection layer on the next slide. This architecture also enables us to free our data warehouse, implemented in Redshift, from having to be what was a jack of all trades. We can now focus Redshift on what it's great at, data warehousing. So this is a high-level diagram of our data lake platform. And again, working from left to right in the diagram. In our implementation, outreach results, for example, call dispositions, SMS responses, those types of things, flow into the system through AWS Kinesis streams on a continuous real-time basis. And we perform near real-time analysis using Kinesis Analytics. And this enables us to radiate outreach activity and volume statistics to our network operations center. Other data, such as custom member profiles, come in through secure FTP and land in a raw data bucket. As a design principle, data always flows from left to right through the platform. This helps to prevent dirty data from ever polluting the lake. Okay, the system takes the raw data and passes it through a conditioning layer. Here, we apply data quality rules, generate metadata for downstream data access and client consumption, and build a metadata index for rapid search and retrieval. We also build a search index, providing various mechanisms for clients to retrieve exactly what they need very rapidly. We move the data through the system at scale using Spark jobs on EMR clusters and store some of the byproducts in DynamoDB. After passing through the conditioning layer, we store the data in S3 buckets that use randomized keys to achieve an operationally effective distribution of the data across partitions. Moving to the storage layer, where the data is now, quote, cooked, we use DynamoDB to store the catalog and metadata, which provides a rapidly accessible map of the data space, which clients can use to find and read data as needed. And IAM policies control all access. On the data access and consumption side, on the right of the diagram, the lake serves a variety of clients using projections. And you can think of these projections as views into the data that are materialized either real-time or are updated on a periodic basis in batch. Two examples include we make ad hoc querying available to our analytics and data science teams using Hive and Presto, and we feed the enterprise data warehouse hosted on Redshift. Both of these are different kinds of projections. Internal clients can access the data through projections or can access it using a read-only API. In terms of the the major services we use. That diagram, is previous diagram, is sort of an architectural soup, so I won't go through all of these, but I'll just highlight a couple of things. In addition to S3, we process incoming streaming data using Kinesis Streams and Analytics. We store our data catalog and metadata in Dynamo. We use Aurora for some internal housekeeping. And at times when we need transactional semantics, we do tend to now default to Aurora for that. Hive and Presto are used to serve our SQL-based clients to perform ad hoc queries and to interface to analysis tools such as Tableau. And we use Cloud Search to index our catalog and some select data for rapid retrieval by downstream client systems. So additional benefits here of the new platform include, we have a robust architecture to support ingest and data processing at scale. We have improved business agility to allow schema on read. We've architecturally separated compute and storage and allow each to scale independently. This has helped us manage costs quite effectively. We've reduced cycle time for end-to-end client analytics by about 50%. Our portal, where customers can view reports and control outreach flows, now receives near real-time updates. In the future, we're considering applying machine learning to data sets to determine if and when a member falls into a given set of clinical categories, helping our customers segment their populations in new and meaningful ways. And all this is possible because of this new architecture. Some key learnings. This has been a very worthwhile project. Some things that we learned along the way that had been sort of ingrained in our culture that we had to rethink. We were storing our name value pairs completely suboptimally, and we were doing too many transformations due to the original storage formats. So going back and rethinking the original storage formats and then the subsequent processing was extremely valuable. So with NorthBay, what we did, the way we set up our, the way we wanted to set up the discovery is we wanted to explore alternatives, and we took a structured approach of proposing hypotheses and then using focused mini POCs to prove or disprove them. This led to an emergent architecture which pointed us toward the data lake. So we didn't wake up one day, or NorthBay didn't come and say, hey, you should have a data lake. This was a process of discovery and hypotheses and proving these hypotheses out that led us down this path. So I can say with confidence the data lake architecture fits our core business and growth plans extremely well. And finally, the AWS platform has served us extremely well, and we're looking forward to having all the services become HIPAA compliant as soon as possible. And that's it. Thank you very much.
Thanks, John. I really appreciate that. I think, Sai, this is the time when we're geared to do Q&A. And if you want to lead that, that'd be great.
Yep. Thanks, John. Thanks, Ali. Let me start with a question for NorthBay here. So, Brian, this is a question for you. Your company has done a lot of these projects and has a kind of pattern recognition from seeing a lot of these projects. What is the key to getting up to a
Yeah, that's a great question.
Start?
And I think that both Scholastic and Eliza have already answered it in part. So when John just mentioned that they've done all the POCs, very important. So I think there are three things that we see that are common across people who do this well. One, they explore a lot of possibilities very rapidly. Two, they pick a problem or two to solve that both have business value and can prove out the technical challenge and whether it can be met. And then three, post that, we'll come back with a roadmap to do the rest. So to apply that, Eliza, as John had just mentioned, has done multiple PLCs that led them to the solution. Scholastic took the same process and did it in a slightly different way. With them, we considered, again, they had almost 6,000 workloads to be transformed. So we picked two or three of the really gnarliest and hairiest that had a lot of business value. And we concentrated on solving those and proving to the business users that they would get everything that they had now plus a lot more. At the same time, it allowed NorthBay and Scholastic to form a one-team model where our engineers and their engineers were working side by side, and we're bringing the insight that we had around doing 70 plus of these projects And they were bringing the insight that came from having lived and developed those systems over the years. So as a matter of fact, this three-step process was so repetitive that we formed a jumpstart around this. And the NorthBay jumpstart basically says, consider the options in the first 2 weeks of a project, spend 9 or 10 weeks head down delivering something that has business value, and then step 3 is come back with a topographical roadmap for the path forward.
Thanks, Brian. Another great question for Ali Khan from Scholastic. What was the key to compressing a 3-year project to 18 months? Ali, can you elaborate?
Yeah, that was a real challenge. I think there were a couple of things. One is we needed to figure out how do we do this, technically, right? How do we actually execute this, and not, have people stepping over each other. So, one of the good decisions that we made was to develop this reusable data ingestion framework, right? And that was really the key, right? We had to make sure that each of the teams was able to use it independently, and we had enough paths into the AS400 system to be able to execute this utility in parallel across teams. So that took some work. So there was that technical problem to solve. And the other problem was really we solved that. The other problem was really how do you manage this from a project management point of view? And that was another challenge as well. Fortunately we'd had a good experience with NorthBay. We had asked them, challenged them to say, okay, so we have 2 teams from you, right? We want to ramp up to 7. And the way that our teams work is, and Brian mentioned this earlier, is that we don't have this model where we bring in an external company and ask them to go and do something for us. They become part of our team. They become part of our process. Our teams are fully mixed, right? They're fully integrated. We have people onshore, offshore, right? They run in our scrums and so on. And to NorthBay's credit, they were able to produce a large amount of staff that had AWS skills, and otherwise we wouldn't have been able to do that, right? So those 2 things, working out technically what it takes to execute, to accelerate a program like this, and 2, being able to staff it, right? And those are both really key factors.
Thanks, Ali. Now a question for John from Elijah. Now that you have moved a large swath of your data and analytics to the cloud, what are the next set of challenges you see addressing?
I think for us, we are an operational company at our core, right? So the operations have to keep moving along, and now we have some of our data flowing through our legacy systems. Just like Ali had mentioned, it's a very difficult balance of having 2 operational systems running simultaneously. So our next challenge is to fully operationalize the data lake, which will mean changing some of our systems that access data to use the lake almost as a data access layer. So in 2017, my plan for engineering, one of the big projects, is to start retooling some of our core runtime platform and some of our internal tools to use the lake exclusively for its data access. And eventually we'll start turning off direct access from the core platform, right? We'll prevent them from touching the S3 buckets directly. We'll prevent them from touching Dynamo directly, and force everything through the lake, which should keep both the data cleaner as we move forward, as well as being able to be projected much more readily.
Thanks, John. Another question for Ali Khan. Could you talk more about the type of the data and the volume and the frequency of data that's being loaded into Redshift and some of the other services?
So we have 2 types of data ultimately, right? We have the the traditional sort of T+1 data that comes in from our operational systems. These come in from our AS400 systems. They're processed every night, and then we have data that is generated from our big data type systems, right? So this is usage data that we have from our devices and apps that are out there. So that's coming in sort of every 15 minutes. In terms of volume, these are not huge volumes, right? These are, the overall size of the environment when we started was about 20 terabytes, so fairly small by data warehousing standards. Now it's sort of double that, and we have between tens or hundreds of gigs coming in every day. So our complexity is not really the volume, right? John certainly has a very different challenge in that they have a massive amount of events that they're capturing. Our challenge is more in tying together data that is very, very disparate, right? So if you think about, Scholastic, we have a very complex customer model, right? Who's the customer, right? It could be the school, it could be the child, it could be the parent, it could be the teacher. We have we have thousands of products, right? And we operate, again, across many channels, digital, we have physical events, we sell actual physical books, and each of these is a very different type of data. So tying that together, right? I didn't even talk about formats. So we have, typical relational data that we capture. We also have, JSON format, semi-structured data that comes in from the devices. So making sense of all of that, that's where the complexity lied. It wasn't that we had, huge volumes per se. Having said that, we did benefit from, greatly reduced processing times, right, in our ELT.
Great. Now, I have a question that can be probably answered by both Ali and John. So one part of the question is, how hard was it to estimate the cost accurately for this engagement or this initiative? And the second one is, have you thought about a chargeback mechanism where you can charge back for your internal customers? I don't know, Ali, do you want to start first, or?
Sorry, could you just repeat the question? It just cut out there.
Sorry. It's a two-part question. First part is, how hard was it to estimate the costs for this initiative, whether it's AWS services costs and other costs, internal costs as well? And the second part of the question is, have you thought about a chargeback mechanism where you can kind of do some internal billing, charge to your internal customers?
Yeah. Okay. So the cost part. Well, part of the value of doing a pilot was to figure out what it would cost, right? We were able after that to build sort of a cost estimation model, right? And it was very rough, and we refined it. And it basically, and because our goal is largely migration, we were able to say, okay, you know what, if you have this size of data environment, right, this many tables, and it's a bit arbitrary, right? Not all tables are the same, not all jobs are the same complexity, but we just sort of put some t-shirt sizing around it and said, okay, if you're moving this amount of elements, you're going to need, this amount of staff. And so we're able to, use that across the lines of business and predict that if we're going to do this for 6 lines of business, we're going to approximately need, this number of people. And the cost was largely people cost, right? The actual, operational cost we're able to manage very neatly because, of the way that Amazon works, right? It's an OpEx model, so we're able to just kind of keep that cost, very, very tight and very under control. As far as the chargeback model, we don't have a fully fleshed out chargeback model here. In terms of, if you are a business unit and you're using this data, then you will pay for that. The way that we have been able to do that partially, though, is to make the business units responsible for their purchase of the BI tools, right? So so the way we work is, we have all this great data now. It's clean, it's quickly available, but what use of it is it if people aren't using it, right? And so we would seed a line of business with 5 or 10 Tableau licenses. We would train people on it, send them for classes, identify a data champion, pair them up with a data guide from our side to train them and support them, and then make them responsible for purchasing further licenses. I realize that isn't really a chargeback model, but that was sort of our first attempt to get the business units involved in directly sort of paying, for what they're using. But there isn't a real chargeback model per se as far as data goes.
This is John. In terms of us trying to estimate costs, we've been on the platform in production on the AWS platform for about 2 years, so we had a sense of what various services cost and the amounts of data that we pass through them, what that would cost. So we had a baseline model to go from our current production systems. And the other thing, like Scholastic did when they did pilots, we did the mini POCs, we could explore the costs of using particular technologies in microcosm, and then build a cost model off that. So we had a pretty accurate view of what the entire project would cost us outside of labor, but we know what our labor costs are as well. We knew that fairly accurately too, so that was pretty good, and we got to a pretty accurate model there. In terms of the chargeback, engineering brought that up once and everyone just kind of smiled and laughed at us. So we had to do something. So what we started to do anyway to at least establish a baseline is we used tagging on all of our resources. So when we bring up a resource or we update a resource, whether it be an EC2 instance or a bucket or something, the metadata associated with the component is allocated one or more business owners or business units. And then we use Cloud Health actually to periodically give us, to slice and dice those costs based on the business unit that's using them. We don't actually do the chargeback now, but finance is able to at least allocate some of the costs across the organization. So it's a little informal, but we at least have an idea of who's using what and how much.
Thanks, John. We have a lot of questions, but we may not be able to get to all of them. So we will definitely reach out to you and answer your questions, but I'm going to ask one last question to Brian. Brian, you mentioned about the one team model. Can you elaborate on that? How does that work?
Sure. We operate in a one-team model with our customers through a few vehicles. First, we work very closely with the business sponsors so that we understand the what, why, and where and how of what they need to achieve. Secondly, as we're doing either the POCs, as we did with ELIZA, or as we're doing that first 3-month POC with Scholastic, we're working very tightly with their technical users. And so, in effect, what we're doing is not them and us. It is a one team that we're following. Now, as far as taking that to the next level, we're typically working in an agile fashion where we and they are working on the same sprint schedule, where we are delivering something every couple of weeks with them. Finally, we're going through the same training, and I think Ali had mentioned early on that we had used sprint coaches. Now, either we'll sponsor them with our client, or the client will sponsor them as they did at Scholastic. But the idea is, we immediately form a single unit that operates under the same procedures, that is hearing the business needs at the same time, and that is agreeing on a set of agile principles by which we're going to deliver the project. We always follow what our customers' best practices are, but if we're asked, that's the structure that we would supply.
Thanks, Brian. I think we're almost at the end of the hour here. I want to thank our speakers, especially our customers, Ali Khan from Scholastic and John Poplo from Elijah, sharing their story with us today. With that said, thank you everyone for taking time to join the webinar today, and enjoy the rest of your day.